Hello, my name is Jared Cruz, and I did this work with some graduate students of mine, Sarah Voss, Isaiah Kent Schneider, and Ren Demeke. In this work, we're trying to understand the development of nature science pedagogical content knowledge during a semester-long nature science course. So for this work, we use the family resemblance approach. And so we found that this approach provides a little bit of flexibility while also providing a wide range of nature science ideas. And so that internal circle, we call that the goals, the work, and the products of science. On the second circle, we call that the social and institutional norms of science. And in the outside circle, we call that the cultural influences of science. So where you get into like how politics and financial systems affect science. Since we're studying pedagogical content knowledge, the other framework that we're using for this study is from Magnuson et al., who identified kind of 5 areas of PCK: orientations toward teaching, knowledge of the curriculum, knowledge of students, knowledge about assessment, and knowledge about instructional strategies. For this study, we're really only looking at 2, 3, 4, and 5. We're not looking so much at their orientation toward teaching. In the existing research of nature science pedagogical content knowledge, we've noticed that there's been a lot of emphasis on trying to describe effective nature science PCK. And that can be really useful because if we can understand how effective nature science teachers think about teaching nature science, that may help us teach future teachers. We did see some developmental studies with like professional developments, but those were oftentimes a little more short term. And we didn't see very many descriptions of how nature science PCK develops in pre-service teachers over a semester-long dedicated nature science course. And we also didn't see very many studies that were using the FRA framework, partially because the FRA framework is a little bit newer. So our research question is, how does pre-service teachers' development of nature science pedagogical content knowledge progress across a semester-long family resemblance approach-based nature science course that included a teaching practicum? So in this course, we had 15 teachers during a semester-long nature science course. We used the core, the content representation tool, and we administered this tool at the beginning of the course, after the first unit of the course, which was really just exposing students to the nature of science. And then the second unit of the course was helping them think about how to teach nature science. And then the final unit of the course is really application, where they're actually getting a chance to teach students. We also interviewed each student, and we did do some classroom observations during the practicum. For our analysis, we used a modified rubric from an existing PCK study. And then we also looked at the core and the interviews qualitatively so that we could look a little bit more deeply at some of the responses. So our results, I'm going to go through these a little bit quickly. This first is just for the goals, work, and product of science, so that inside circle. And one of the things I want to draw your attention to is how from time 2 to time 3, we see a big jump in the student difficulties, representations, explicit reflective, knowledge of the explicit reflective framework, context, and assessment. And we're going to see that pattern in the other 2 areas as well. And so that is because from time 2 to time 3 is when we actually started talking to them about how to teach nature science. From time 1 to time 2, we were just talking about nature science itself. And so again, we see that same pattern. From time 2 to time 3, we see a big jump in some of the teaching aspects related to pedagogical content knowledge. We also see in some of the layers of the FRA, from time 3 to time 4, a fairly large jump in the rationale of why they should be teaching nature science. And so again, although we do see a pretty big jump from time 2 to time 3 here as well. So this is the data on the impact of society and culture, the outside circle of the FRA. And so from the quantitative data, we can make some insights. One, it's important to talk explicitly, or to teach explicitly and reflectively about how to teach nature science, not just about nature science itself. With the role of context in internally nature science rationales seems, especially from time 3 to time 4, we saw that little bit of jump in some areas. And that seems to be maybe connected to, that's when we started talking about social scientific issues and the role of nature science in understanding some of those issues. And it was interesting that the 2 outer rings of the FRA kind of lagged behind the first ring. And so there may be some difficulties, some higher levels of abstraction that make those outer rings of the FRA a little bit more difficult. So now what we're going to do is we're going to zoom in on a single student to kind of illustrate some of the more nuanced qualitative pieces of this study. And so on this is again the first ring, the goals, the work, and the products, that inside ring of the FRA framework. And I'm going to jump around here a little bit. I'll let you can always pause the video to see the individual quotes from the student that kind of backs up our points. But our main points is that the rationale seemed to progress mostly towards the end, like they were actually getting towards evaluation of science. The instructional strategies, especially on this inside circle, it was interesting. This student's instructional strategy remained heavily rooted in implicit or general approaches. And we think that this might be because that inside ring is so easy to confuse with process versus nature or science. That is, the student is recognizing that, like, if I want students to understand the goals, work, and products of science, I need to have them working like scientists. And that is true. But we also need to have them reflecting explicitly on like that work and why scientists might do that work, and the fact that scientists do work similar to how the students are doing it in class. Their knowledge of students progressed as we might expect, moving from general lack of student knowledge to specific misconceptions to student particular difficulties with nature science within science content, making those kind of understanding how science and nature science content and nature science content are different things. And another interesting thing about this student in this inside ring was that their conception of explicit and reflective was actually tied to assessment, which makes some sense because explicit reflective questioning is a way to at least formatively assess students. But it was interesting that they didn't talk about explicit reflective questions in the instructional strategies section of the core. So now we're moving out to that next ring, the institutional and social norms. Again, there was less progress overall. The rationale remained vague until time 4, which I talked about a little bit earlier. Knowledge of learners recognized the importance of the difficulty students might have with abstractions, especially later on in the course. And eventually the teacher put inclusion of explicit reflective questioning in the assessment section of the core, which again is somewhat interesting. So when we go to that outer ring on the impact of society and culture of the FRA, the rationale started off very circular and eventually moves towards more informed citizenship, which makes some sense because that's especially at time 4 when we're talking about the role of nature of science and understanding socio-scientific issues. The teacher included more contextualized approaches towards the end of the course, which again we're pleased to see because more contextualized approaches allows for that more like those social and cultural issues that are coming up in the nature of science really need to be done with a more contextualized approach. Again, they recognize the difficulties with abstraction, and then the assessment knowledge for this outer ring really kind of started and remained fairly general. There wasn't a lot of progress there. And so the insights we can make from the qualitative case is again, those cognitive epistemic, that inside ring of the FRA remained heavily process oriented. So helping students connect, yes, we want students to be acting like scientists, but we also want them to be reflecting on the fact that what they're doing in their actions is actually like what scientists do, and making comparisons and contrasts between their work and what scientists actually do. The notion that the explicit reflective framework was interpreted as part of assessment, maybe helping the teachers make connections between how assessment and instruction are kind of two sides of the same coin. And then we thought it was interesting that there really wasn't a lot of change in their knowledge of students caused by the opportunity to teach science from time 3 to time 4. So our recommendations are here. We want to ensure that teacher education includes explicit reflective instruction about how to teach nature of science, include highly contextualized nature science instruction to support development of strong rationales for nature science. We want to increase support for those outer rings of the FRA. We may want to put more effort into helping the teachers delineate between implicit and explicit NOS instruction. And there may need to be some effort spent in helping the teachers really connect their practicum or their experiences teaching nature science to their thinking about teaching nature science. So here is page 1 of our references, page 2 of our references, and we'll take any questions in the live session later on.